The images look like something out of a movie, a tiny asteroid tearing through space at a speed of 33,000 miles per hour before streaking across southern Russia. Cameras caught sight of the white trail as it headed across the sky. And then this.
Hey everyone, welcome back to the channel. Today, we're diving into a truly eye-opening event, the Chelyabinsk incident. Picture this, February 15th, 2013, over Chelyabinsk, Russia. An asteroid, heavier than the Eiffel Tower, crashes into the atmosphere and explodes 30 kilometers above ground. Now, this wasn't just your average explosion. It was brighter than the sun, yet eerily silent for a whole 90 seconds before the shockwave hit. Imagine witnessing that. People were captivated by the smoke trail in the sky, until BAM. The shockwave shattered windows, injuring thousands with flying glass. It was chaos.
So you see all these videos of people, look at what was that? They see the smoke trail in the sky, and oh, that's amazing. And then, just when you think nothing's going to happen, the shockwave hits and it blows out the windows. 1,000 people got glass in their face, in their eyes, because they're looking through the windows.
What's even more astounding is that on the very same day, scientists had predicted another asteroid would do a close flyby of Earth. And guess what? They were spot on. But here's the kicker, while they nailed that prediction, they completely missed the one that caused havoc over Russia. And here's the harsh truth, this isn't a one-off. We're not as good at detecting asteroids as we'd like to think. Stick around because in the next parts, we'll dive deeper into why our asteroid detection game needs a serious upgrade. Hey there, welcome back to the channel. Today, we're delving into a topic that's both fascinating and terrifying, asteroids. Did you know that since 1988, over 1,200 asteroids larger than a meter have collided with Earth? Shocking, right? And here's the kicker, we only spotted 5 of them before they hit, and even then, we had less than a day's notice. So, what's going on here? With all our fancy technology and telescopes, you'd think we'd be better at spotting these potential threats. But the truth is, we're still struggling. But why? That's the big question. We'll explore that in just a moment. But first, let's talk about the elephant in the room, the chances of a massive asteroid wiping out life on Earth. It's a scary thought, I know. But here's the deal, while the probability of a catastrophic impact is relatively low, the consequences would be catastrophic. That's why it's crucial to stay vigilant and improve our detection methods. So, if we did spot a big asteroid hurtling towards us, what could we actually do about it? That's another question we'll tackle in this video, so stick around. Now, let's get into the nitty-gritty of asteroids. These space rocks are essentially leftovers from the early days of our solar system. Picture this, 4.5 billion years ago, rocks and dust clumped together to form protoplanets. Some of these evolved into the planets we know today, but many broke apart, giving birth to asteroids. Most asteroids hang out in the main asteroid belt between Mars and Jupiter, but some venture closer to Earth, known as near-Earth objects, NEOs. And let me tell you, these NEOs are the ones we need to keep an eye on because they pose the greatest threat to our planet.
So this is an iron meteorite, and essentially it's the piece of a core of a small planetary body, basically a small planet, that formed 4.5 billion years ago, differentiated, so the core material fell out, and then this thing was smashed apart by a collision with another asteroid. That's the oldest thing you'll ever see.
In fact, the late Stephen Hawking considered an asteroid impact to be the single greatest threat to life on Earth. It's a sobering thought, but one that we can't ignore. So, why are we struggling to detect these asteroids before they strike? And what can we do to improve our odds? Stay tuned as we dive deeper into these questions in the next parts of this series. Don't go anywhere. Finding asteroids is no walk in the park, folks. It's actually quite the challenge for several reasons. You see, most of these space rocks are spotted by ground-based telescopes. Picture this, it's astronomers snapping a sequence of pictures, scanning for a moving dot amidst a sea of stationary stars and galaxies. Sounds tedious, right? And here's the kicker, asteroids aren't exactly attention grabbers. They range from tiny meters to kilometers in size, making them mere specks in the vastness of space.
You have a 10-kilometer impactor like the KT extinction event every 100 million years or something like that. So the probability of getting it in 1 year is 1 in 100 million. So you have 1 in a million chance of dying from a 10-kilometer impactor. But because we know that there are no 10-kilometer impactors, with a path that intersects the Earth for the next 100 years, your chance of dying from that is actually 0. So work done already has reduced that down, from 1 in a million to nothing.
Even a small one can wreak havoc, like the Chelyabinsk meteor, which was just 20 meters in diameter, about the width of 2 school buses. To make matters worse, asteroids are rough and dark, reflecting only a measly 15% of the light that hits them. So, our best shot at spotting them is when they're fully illuminated by the sun. That's why over 85% of the near-Earth asteroids we've found were in the 45 degrees of sky directly opposite the sun. Sneaky, huh? But here's the kicker, any asteroid coming from the direction of the sun is practically invisible, just like what happened with Chelyabinsk. And get this, out of the million asteroids we've catalogued so far, a whopping 24,000 are near-Earth objects, ones that demand our close attention. But here's the rub, even if we spot an asteroid, predicting its path is like trying to read tea leaves. You need years' worth of data to make a decent guess. And even then, there's a fundamental limit to how far into the future we can predict. Why? Because of pesky things like dynamical chaos and the gravitational pull of planets, which can throw an asteroid's orbit into chaos faster than you can say, Houston, we have a problem. So, yeah, finding asteroids and predicting their paths isn't exactly a walk in the park. But hey, knowledge is power, right? Stick around as we unravel more mysteries about these space rocks in the next parts of this series. Don't touch that dial. So, here's the deal, when it comes to predicting the paths of asteroids, we've got a bit of a time limit. In practice, we can't accurately forecast anything beyond a century into the future. Yep, you heard that right. The maximum time we can reliably predict where a space rock will be is about 100 years. And that's a problem because, let's face it, if one of these bad boys does hit, the consequences will be nothing short of catastrophic. Now, take a moment to consider Barringer Crater in Arizona. This massive dent in the Earth's surface is named after Daniel Barringer, a mining engineer who was convinced it was formed by a meteorite impact. Back in the early 1900s, when everyone else was still scratching their heads and blaming volcanic activity, Barringer was out there staking mining claims, convinced he'd hit the jackpot with a metallic meteorite worth a cool $1,001,903.
Yeah, so people are motivated by money, right? So they thought, hey, we can get some iron for free, basically. So they started to drill in the bottom of the crater and found nothing. And then they started to do other exploratory drills, and this went on for years and decades. They started to drill sideways. Somebody said, maybe it came in from an angle, which it did, and maybe the iron is not under the middle, but maybe it's over there under the wall. So he was doing drilling. If you go there, you can see the drills now. He was drilling around the wall, he found nothing. So what they didn't realize is when you have an impact at high speed, it's not like you're throwing a stone into a brick wall, and it makes a hole and sticks in there, or just bounces off. It's explosive. It's like totally explosive. So the kinetic energy of the projectile comes in maybe 30 kilometers per second. The kinetic energy of the projectile is big enough to completely vaporize the projectile. It turns it into a gas. And that gas is super hot and super high pressure. And it explodes, and it blows out the crater. So the projectile doesn't really exist after the impact. Little pieces can survive. But this 50-meter body was basically obliterated. So he was looking for something that did not exist.
But here's where things get interesting. Despite years of drilling and digging, they found zilch. Nada. And you know why? Because when a meteorite slams into the ground at crazy speeds, it doesn't just neatly burrow itself into the earth like a stone into mud. Oh no, it's way more explosive than that. Think of it like throwing a firecracker into a brick wall. Boom! That's the kind of energy we're talking about here. So, as you can imagine, trying to locate the remnants of a meteorite impact is like searching for a needle in a haystack.
Shattered windows and damaged buildings. There were reports of more than 1,000 people injured, mostly from glass and debris.
It's no wonder Barringer and his crew came up empty-handed. But hey, that's the nature of the beast when it comes to asteroid impacts. Stick around because in the next parts of this series, we'll dive even deeper into the wild world of asteroids and what we can do to protect ourselves from their destructive potential. So, as we wrap up today's exploration into the fascinating and often daunting world of asteroids, it's clear that these space rocks are not to be underestimated. From the Chelyabinsk incident to the enigmatic Barringer Crater, the stories of their impact on our planet serve as stark reminders of the potential dangers lurking in our cosmic neighborhood. But fear not, fellow space enthusiasts, for knowledge is our greatest ally in the face of uncertainty. By continuing to study and understand asteroids, and by bolstering our efforts in detection and mitigation, we can work towards a future where the threat of asteroid impacts becomes a thing of the past. So, until next time, stay curious, stay informed, and keep your eyes on the stars. Together, we'll navigate the cosmos and ensure a safer, brighter future for generations to come. Thanks for joining me on this journey, and I'll see you in the next video.